So in this lecture, I came up with one important numerical of your 2 degree of freedom for your vibration, and this kind of question has been asked in your previous year for generally for 2 marks in your GATE Aerospace. Okay, and we will see how to solve using determinant method, and we will try to understand some concept in that, and we will see how we can solve quickly as soon as possible. Okay, because wait, in a GATE exam we need to save a time, right? So okay, this is for your Aerospace 2023. Okay, and generally if you see your your structure vibration part generally ask for 4 marks or 5 marks. You can expect to 2022 this year they have asked 2 questions for 2 marks, and I think one question was also numerical. So generally they can ask 4 to 5 marks in your GATE exam. So kind of heavy weightage itself, vibration topic. Okay, so okay, let's see the question. Okay, vibration, right? Now let's see the question. So this is the NAT type question. So this is the 2 degree of, so the system they have given of 2 degree of freedom. How we can predict 2 degree of freedom? Directly, if you see the masses or if you see the displacement are 2, which is different. Okay, so you can, in this way you can predict this is 2 degree of freedom system. I'm not going into that how to judge that the 2 degree of freedom. That is simple, but I'm not going into that as of now, because I want to discuss concept in that. So they are asking natural frequency of the given system. Omega 1 they have given. Okay, omega 1 and omega 2 they have given, where omega 1 is lesser than omega 2. What is the value of alpha? Now if you see that in your 2 degree of freedom system, always omega n1, which is your natural frequency, always will be lesser than omega n2, and the similarly omega n3, so on, for 3 degree of freedom system or multi-degree of freedom system. Okay, so always your omega 1 will be the smallest natural frequency, then in a increasing order of natural frequency. Okay, so this is, they, if they don't want to give, they cannot give this, but just for the clarification they have given. Okay, now they are asking, what they are asking, they are asking what is the alpha 1 in this case. Okay, okay, let's see. This is a very simple straightforward question if you know the concepts. Okay, now what I will do, just we need to use the determinant method. So I will solve by determinant method. So this is the simplest way if you can solve this determinant method, and just we need to use the quadratic equation formula to get omega 1 and omega 2. Okay, so if you see, this is 2 degree of freedom, right? So when you whatever degree of freedom you have, similarly correspondingly you will have that number of natural frequency. That means if you have a 2 degree of freedom, that means you will have a 2 natural frequency of the system. If you have 1 degree of freedom, then you will have a single natural frequency of the system, and if you have infinite, then correspondingly you will have a infinite natural frequency of the system. Okay, so this is the one important note for you. Okay, okay, let's see the before that. In 2022 or 2021, they have asked the question from your 2022. They have asked one question from 2 degree of freedom or multi-degree of freedom, and one question from your I think critical damping they are asking for 2 marks. both are 2 marks. Okay, and 2021 similar question, they have asked the critical I think critical, what is the critical damping of that system. They have given this kind of diagram, spring dashboard attachment, and this kind of system they have given. So they are asking in that, I think, critical damping. Okay, now let's focus on the question what they are asking. So in that they are asking what is the alpha value in the omega 1 natural frequency. This is nothing but no natural frequency. Okay, now, so this is the strictly the formula we have, direct formula we have. Okay, k1 plus k2. I will explain what is k1 k2 in this, and what to remember for your gate exam. I will explain that, I will tell you. So just write down the formula if you want. So this is the again very important formula. So what is this? This is just determinant, and if you see, first of all you need to block this formula, because this is the very important formula to solve the 2 degree of freedom system. Okay, we need to buy hard this. So if you see that omega 1, that m1 is a mass of the first mass. This is first mass, representing first mass, and k1 is the stiffness of the first spring, and k2 is the stiffness of the second spring. Again k2 is the stiffness of the second spring, and again same one. And again if you see, this is m2, that means mass, second mass. What is second mass you have? Then again this is the k2, stiffness of the second spring, and k3, as of now we don't have a k3, so we will assume it as a 0. Okay, I hope this is clear. Okay, now I'm writing the given data from the system. If you see the system, so in this place you have a mass 1 is you have a m, which is this one. Okay, m2 you have a this 3m, thrice of m. Okay, I hope it is clear. Now if you see the k1 you have a stiffness, k1 is a k in the system, k2 we have 2k. Okay, and we don't have a k3 in this system. Okay, so we assume it as a 0 for the our understanding. Okay, so stiffness, third stiffness they have not given in the system. Okay, now what you need to do, just you need to substitute this all the values of the system in this determinant form. You just need to substitute. Okay, so what I will do, I will substitute here. Okay, then we have to solve it and equate it to, at the end we need to equate it to 0. Okay, so if I substitute the values, now you know m1 is nothing but m, and this omega will remain same. This is natural frequency, we need to find out this omega. Okay, plus k1 is nothing but k, and k2 is nothing but 2k, right? And k2 is nothing but 2k again with a negative sign. This is negative sign is given by the formula. Okay, so you have to use that again, 2k, this one. And now if you see m2 we have is a 3m, right? 3m into omega square, plus k2 we have a 2k, and k3 we don't have, right? So we substitute it as 0. Now you need to equate it as 0. Now what you have to do, you just need to solve this determinant, and then you will get your natural frequency of the system. How much you will get? 2 natural frequency you will get from solving this determinant. You can see this is a square in square form. So okay, let's see the next slide. Let me solve in the next slide. Okay, so if you see now, if you solve that determinant, just you need to multiply from here to here, then take a negative sign, then multiply here to here in the determinant, and at the end equate it to 0, right? So that is the, I hope you know how to solve the determinant, just basic mathematics, right? Okay, so minus minus will become plus 3m square omega. Just you need to multiply that. Okay, I'm directly writing, I have already, so I will not waste much time in that. Okay, just you need to multiply that, 6k square. Now that minus 2k square and minus 2k square is here, right? So minus minus will become plus, and before that we need to use subtraction, negative sign, right? So that become plus or minus, it become minus, and equate it to 0. Now simplify this. 3m square omega to power the 4 minus 11 km omega square. Pardon me for any mistake. I forget to written anything. Okay, maybe. So this becomes 2k square is equals to 0. Now if you see this equation, this is your nothing but quadratic equation. Let me write that so it will be more clear. So you see this becomes your quadratic equation. Please compare this equation by this. What is this equation? This is nothing but your quadratic equation, right? Now I hope you know how to solve this quadratic equation. So if you compare this both the equation, you will find the coefficient of A is nothing but 3m square, coefficient of B is nothing but minus 11 km, and C is nothing but 2k square without the negative sign. Okay, now I hope you understand now where I'm going to use this coefficient. Just using the equation omega 1 and omega 2, both will have the square. Okay, and I hope you know the formula minus b plus minus under root b square minus 4ac divided by 2a. I hope you are aware of this formula. Okay, now I'm just directly putting all those these values in this formula, and let's see. So that minus and minus will become plus, plus minus under root b square will be k square, and a square will become minus 4a and c. If you multiply, and if you multiply by 4, it will become 24 k square m square divided by, we have a 2a, that means it becomes 6m square. Okay, now you can simplify this. I hope omega 1 into omega 2 square. So omega 1 is your first natural frequency and omega 2 is your second natural frequency. I hope you know this. Omega 1 is lesser than omega 2. The question itself they have provided. Right? If you solve this now, 11 km, k is nothing but stiffness and m is nothing but mass. Okay, and this becomes now 97 k square m square divided by 6m square. Right, now again if you further simplify this, it will come out as a 9.87 km divided by 6m square. Now what you have to do now from here it will be separate out for omega 1. Okay, and this is for your omega 2. So for omega 1 we know that omega 1 is least natural frequency of your system, right? So from here you can, if you take negative sign, then you will get a least value for omega 1. Okay, so I'm taking the negative sign. Okay, so if you take a negative sign, minus taking negative, right? So it becomes 9.87 km divided by 6m square, right? And if you solve this one, and take shift this square to the left hand side, you will directly end up with 0.91 under root and under root k by m, right? And if you know, in the question they have given omega 1 is equals to alpha under root k by m, they have given, right? So if you see in this, omega 1 is nothing but 0.4 438 under root k by m. So this one is your natural frequency, which is first natural frequency of the system. Natural frequency of the 2 degree of freedom system, right? So if you compare this both these two, you will end up with the, this is nothing but omega, and if you know the convention, sign convention, okay, if you compare this, alpha will be 0.438, and you can match your answer with this expected answer they have given for the numerical answer type range is they have given 0.432 to 0.44. So you can round off to the 2 decimal place, which will become, alpha will become 0.43 or 44, you can write. So I hope you got how to solve for 2 degree of freedom. And let me also solve for the omega 2. Then omega 2 they have given in the question beta under root k by m. Just you need to solve for the, just you need to take the positive sign, because positive sign will give the bigger number for the omega 2, right? So omega 2 square will be this, okay, yes, 9.87 km divided by 6 m square. Now if you solve for the omega 2, shift this square and it will become under root in the left hand side, it will automatically, you will get this one. So in this, beta will be 1.86. Now you can see your alpha 2, your omega 2 natural frequency, second natural frequency is greater than first natural frequency. You see this is 1.86 beta and alpha is 0.438. Now I hope you got how to solve for 2 degree of freedom system and how to use the determinant form. So that determinant you have to remember to solve the second 2 degree of freedom system, right? Okay, if you have any doubt, you can ask me in the comment section. I will try to answer there. Okay, and we will meet in the next lecture with a new concept. Thank you.